All right, we're doing all of 3-5, and you need to memorize this time. You're going to have some stuff to memorize today. We do have a quiz coming up on Friday, and these will be on there. You need to know them, okay? All right, so here we go. Trig derivatives. It's just a matter of studying them. Are you good at studying things? No, not this week. Trig derivatives. Okay. Here we go. Let's go through them all. What's your favorite trig function? Is it sine? F of x equals sine x. Sine's my favorite trig function. All right, here we go. Shh. We've already done this one. The derivative of sine is cosine. Very good. We did that. We actually graphed sine, and then we graphed the derivative on our calculator, and we found out that it was cosine. Okay. If f of x is cosine of x, then the derivative is negative sine x. Okay? So there's two. Why? I love that you ask why. That is so good. I can prove it by the definition of, the limit as h goes to 0. I can prove it for you.
It's okay.
No?
I was asking, God, why? Why would you make it?
Oh, what? Like, why? Okay, got it. All right, now tangent, all these are going to be a little interesting, so here we go. The derivative of tangent is secant squared x. Yep. No. Okay, so those are our 3 trig functions that we do a lot. Now let's do the other 3. Here we go. Let's take the derivative of, let's say we have f of x equals cosecant x. Then the derivative is, bless you, derivative of cosecant x is negative cosecant x cotangent x. They get kind of complicated, don't they? Okay, let's go ahead and do f of x is secant x now. The derivative of secant x is going to be secant x tangent x. Those are really closely related, though, if you look at them. You see that? So cosecant is negative cosecant cotangent. They both start with c's. And then secant is secant tangent. It's the opposite functions, really. Okay, and then finally our last one, which would be cotangent x. The derivative is, let's see if you can guess it. Do you see tangent up here? The derivative of tangent was secant squared. Derivative of cotangent is going to be negative cosecant squared. Those kind of go together. Okay, so there they are. Your 6 trig functions, you got to know those. You got to memorize them. Now, here are going to be some examples that we're going to do with these. So, number 1, we're just going to be taking derivatives now. Okay? So let's say that we're going to find y prime or dy dx, whatever they ask for. Okay, it's the same thing. Find y prime or dy dx. And let's do quite a few, just so you can get used to these. Let's say I have y equals x cubed sine x. X cubed sine x. Now, you need to look at this and recognize that there are 2 functions here, and they're being multiplied together. And when I have 2 functions being multiplied together and I'm taking the derivative of them, I have to use what rule? Product rule. So we're going to do a b prime plus b a prime. Do you remember that? Product rule? Mm-hmm. Okay, so here we go. Y prime equals. So think of this x cubed as being a and sine x as being b. So we're going to do a, which is x cubed, times b prime. And what's the derivative of sine? Cosine. That's the one you won't forget. That one's pretty easy. Derivative of sine is cosine. Plus b, which is sine x, times a prime, which is 3x squared. Now there's not really anything to simplify. They do want you to rewrite this. You can write this as x cubed cosine x plus 3x squared sine x. They like to have that in the front of them so it doesn't look like it's sine of 3x cubed. You know, it's totally different. It would go up front. Okay, pretty good? Pretty good. Okay, let's do another one. B. Let's do this one. Y equals sine x over cosine x. Now, let's do this. You know that sine over cosine is what? It's tangent. Okay. But I'm going to show you that you can use the, what's that called? Quotient rule to get the derivative. Like, let's say you're on a test and you have to find the derivative of tangent and you forget that it's secant squared, right? That's one that you might forget. You can always change tangent into sine over cosine and do the quotient rule. So here we go. Let's do quotient rule. So we're going to go low, d high. What's the derivative of sine x? Cosine x. Good. Minus high, which is sine x, d low. What's the derivative of cosine x? Negative sine x. Good. Over the square of what's below. Cosine squared x. Okay, now let's fix this stuff. Cosine times cosine is cosine squared. Negative sine times negative sine is positive sine squared. Oh, do you recognize that? Yes. What is cosine squared plus sine squared? It's 1. That's the one identity you remember, right? Remember all your identities? They were terrible, like sine, cosine, cosine, sine. Yeah. So this is 1 over cosine squared. And what is 1 over cosine squared? It's secant squared. You love this. Molly, don't lie to me. You love this.
Molly don't care. She'll be fine. She'll be fine. Yeah.
See, this is reciprocal trig function.
She's always fine.
Doesn't mean I don't hear it.
Okay, let's do another one. Let us see. Y equals. They're taking all the little kids over to the middle school for a play today.
For what?
Well, middle school play.
Why don't they walk over?
So my son's probably driving by on a bus. Okay, let's do this one. Now, the last one you could have simplified the function first, said it was tangent, and then do the derivative of tangent, which is secant squared. We could have. I just wanted to show you that it works using quotient rule. This one you cannot simplify, okay? You can't. There's nothing you can do here. I mean, you probably could do 1 plus sine x top and bottom, try and get it to look something else, but you don't have to. So we're going to do quotient rule here, okay? So here we go. Y prime equals. So we're going to go low, d high. So the derivative of cosine x is negative sine x minus high, which is cosine x, d low. And the derivative of 1 minus sine x is, well, the derivative of 1 is 0. Derivative of negative sine x is what? Negative cosine x. Yep. Over 1 minus sine x squared. Okay. Now we're... No, because it's a negative sine x. So the derivative of sine x is cosine x, but there's a negative in front. So like if you have y equals negative sine x, and I had to take the derivative of that, the derivative would be negative cosine x because of the constant negative 1 out front. All right, now let's fix it up. Are you ready? Here you are. Let's distribute this, and we get Huda. What up, G? You made it. Whew. There you go.
This essay's killing everybody.
Plus sine squared x. Over here, negative cosine x times negative cosine x is positive cosine squared x. This one's really good, you guys. You'll see.
Yeah, we know.
Thanks, Trevor. All right, so then you get up top, we can simplify this because right here, once again, sine squared plus cosine squared is 1. So this is 1 minus sine x over 1 minus sine x squared. Ooh, look it. I have factors that can reduce. So I'm going to reduce this with one of those, and I get y prime is 1 over 1 minus sine x.
Oh, wait, there's more.
No, that's it.
Wait, no, we can't. 1 minus. Oh,
Yeah, you could leave that. I know, sometimes that's one of the hardest parts is when can I stop, right? You can't. There's no stopping. Okay, let's do some more. Letter D. Let's say that y equals secant x. We want to find y double prime. We're going to find the second derivative. Okay? Now, you should pay attention. Who'd you say that to?
Jack.
To Jack? No, Jack doesn't need to. All right.
It's crazy. We're coming away.
Jack, are you going to take this second semester or are you going to drop? Oh, excuse us. Whoa. Would you like to come up here and teach it? Here, Jack, you can make 2 cents today. Okay. Make some pennies. All right. Let's go. That's so rude. Let's go ahead and find y double prime. So first we need to find y prime. So what's the derivative of secant x? Do you need to look back? Okay. Secant x tangent x. All right, so that's the first step. Yes, you see it, Josh. And now we're going to find the second derivative, and we have 2 functions. So we're going to do product rule. Yes. Product rule shows up a lot. We're going to learn a little something called
Can't you just take it?
chain rule, and then it's a whole new ball game. Yeah?
Can't you just separate it? And just take the. No, it's not. When you're multiplying, you can't do it.
No, you can't. Yeah.
Adding.
Secant tangent. So here we go. A b prime. So secant x times the derivative of tangent x is secant squared x. I did not make calculus. Okay, that would be Leibniz or Newton, whoever you decide. All right, a b prime plus b times a prime. What's the derivative of secant?
Right there.
Secant tangent, right? Okay, this one's not so bad. And then you just clean it all up. What is a secant times a secant squared? Secant cubed. And then this would be secant tangent squared. You can leave it like that. If you feel so inclined to factor out a secant, you can, but you don't need to. Okay? All right, are you feeling pretty good about these? You need to memorize them? Okay, I have one more thing to talk to you about.
Is it long?
No. That really should have been part A, and this is part B. So if you want to write a part A up top, that would be cool. All right. This next part is all about, it's called simple harmonic motion.
Harmonic?
Have you done this in physics? No?
We don't know like terms.
Oh, okay. Harmonic motion is like, it kind of looks like this. Like, let's say that you have some sort of weight at the end of a spring, okay? And it's just resting there. And then you take that weight and you pull it down. Okay, can you picture that? You pull it down. So here's the resting position. You pull the weight down to here. And what's that weight going to do? It's going to spring up, and it's just going to bounce back and forth, right? Well, what happens is you end up getting a nice little sine wave or a cosine wave a lot of times, okay? So here we go. You're going to like this. This is not that hard. I know it sounds pretty bad. But what we're going to do is we are going to find the velocity, the acceleration, and here's a new one. I talked a little bit about this the other day. Jerk. The jerk. Okay? if you're in a car and someone keeps accelerating really fast or taking off the gas and pushing it, and that's a very jerky ride, right? They're being a jerk to you. Get it? Jerk. All right, so jerk is the change in acceleration. Okay? So velocity, so let's say you have the motion of something, okay? And you take the first derivative of that. That is velocity. And then you do the change in velocity. Well, the change in your speed is the acceleration. Right?
Can't V prime also just be?
Yes, V prime. And then, now we have the change in acceleration, which is J of t. People don't like my J's, and that's okay. It's the third derivative. You ready? Let's do number 2. All right, suppose that we are given S equals 5 cosine t. So let's say we have a harmonic motion of a spring and it's being stretched 5 units beyond its resting point, released at a time t equals 0. So t is time in seconds. S is going to be, I don't know, meters or something, whatever, feet, doesn't matter. Okay, so here we go. We want to find the velocity at t. They don't give me a specific t, they just tell me to find the velocity. So velocity would be the first derivative. So what's the derivative of 5 cosine t?
Negative 5 sine t.
Perfect. Negative 5 sine t. Okay? 5 is just a constant. Leave it out front. Take the derivative of cosine as negative sine. Multiply it. All right, let's find the acceleration now. The acceleration is the second derivative. So what's the derivative of negative 5 sine t? Perfect. Yep. Negative 5 cosine t. So the derivative of sine is cosine, but then you have to multiply it by that constant there. And then let's find the jerk. Where's the jerk at? There he is. Everyone points to Jack.
Jack, what is a cat?
What? How is cat a jerk? Cat's never a jerk. And the derivative of negative 5 cosine t would be what? Perfect. 5 sine t. It just keeps bouncing back and forth between them. Isn't that interesting? Okay. Finally, last one. Number 3. It says that we have a falling object. Maybe we've thrown Jack off that building.
That's incredible threat.
Yeah, I don't feel safe in this school.
Every son said, right? Everyone's like, that's
That's oh, yeah, you're right. I don't feel safe in here. I'm sorry, Jack. All right, S equals 16t squared. It's actually going up. I don't know why they say this is a falling object when it's 16t squared. It's weird, huh? Okay, anyways, yeah, so that's S. So S equals 16t squared. That looks like something's going up to me, but whatever. Let's find the velocity, the acceleration, and the jerk. That's it. So the velocity would be 32t. The acceleration would be 32. And the jerk would be 0. There's no jerks. Have you? In here?
It's the same thing.
Same thing with jerk. Exactly. Yep. Okay.